Hey everybody, and welcome to the first video of the course. This video simply builds on what we started in class on the first day, and in particular I'm going to give you an introduction to data types, numeric data types to be precise, and arithmetic in C++. So just as a reminder from the first day of class, commands in C++ end in a semicolon. So this is something that beginners forget a lot, and then they don't understand why the code doesn't run. But keep that in mind. I'm not going to mention it during the video because I mentioned it in class, but your commands like a cout statement must end in a semicolon. And here's a little reminder with some sex appeal here, okay? This guy with smoking eyes is telling you, please don't forget the semicolon. So as a setup for what we're going to do, let me just remind you that we now know how to make a computer tell you things. We know how to make a computer print things to the screen with a cout statement. Okay, a cout statement is simply a way of making a computer tell you something, of printing text to the screen. So this cout statement right here will tell me something that is just so true. You know, the computer will tell me, "You are so handsome," and I'll say, "Oh, thank you, computer. You are so right." So suppose you want to write a program that has some interaction with the user, though, because cout statements are just the computer telling the user something. This would require the ability for the user to tell something to the computer. Okay, so cout statements are the computer telling the user something. How do you make that flow the other way? How do you allow the user to tell the computer something, to give the computer things? So just as an example here, suppose you want to write a program that lets a user tell the computer the side length of a square, and the computer prints the area of the square to the screen. What would that program look like? Well, here's what it would look like. The user gives the computer the side length L. The computer calculates L times L because the area of a square is just the side length squared. And then the computer prints the result to the screen using a cout statement. Okay, so the user inputs something, the computer does something in the background, in this case, this calculation L times L, and then the computer gives the result to the user via a cout statement. Okay, so the question is, well, how does the user give the computer the side length? So before I show that to you, let me give you all of the abstract setup here. So I'm going to talk us through this paragraph. This won't make too much sense until we actually do some examples, but bear with me. This will all make sense once we actually do something with it. At the very least, if you're going to hand the computer something, you want to give the computer a number representing a side length, the first thing the computer has to do is create a place for that side length to go. The computer needs to create a storage space for the thing that the user is going to hand it. Okay, so the computer must create a place for that length. Such a created space for the storage of something is called a variable. The process of creating such a space, of actually setting aside the space, is called declaring the variable. Variables come in all sorts of types. The variable could be created to store a whole number. This is type integer. To store a decimal, like 3.7. That will be type float. Or to store an English sentence, something of type string. Or whatever else. You know, there are lots of other types. Okay, so we're going to make this more concrete in a second. But the big picture here is you want to hand the computer a side length. A side length is a number. Right? It's like 2 or 7 or whatever. So what you would need to do is create a storage space for a number. The creation of such a space is called declaring it. The space you create is called the variable, and you have to decide what type the variable is. So a side length is not an English sentence, among other things. So the variable you are going to declare, that you're going to create, must be created to store a number. So here's some more big picture setup. A variable is like a box in which you want to store something. So just like in reality, if you want to store something, you first need to decide what kind of box is appropriate for the thing you want to store. So if you're going to put a TV in storage, you need a big, sturdy box, right? But if you're going to put a couple of pencils into storage, you need a small, presumably not that sturdy box. You can get away with a small, flimsy box. So that's the idea here. A variable is simply a box. The box comes in all sorts of shapes and sizes. You can have an integer shape size, you can have a decimal shape size, or an English sentence string shape size. So just like in reality, there are all sorts of different ways to store things, all sorts of different kinds of boxes. The same is true in C++. For this video, we will focus on two types of variables. Variables designed to store whole numbers, so type integer or long. I'll tell you what these mean in a second. And variables designed to store decimals, float or double. Okay, so let me just summarize what these data types are. Data type int is short for integer, is used to store whole numbers, either positive or negative, that aren't too big. So things like 7 or negative 15,000, those aren't too big. Data type long is used to store really big whole numbers, so 100 trillion or something. Data type float is used to store decimals without too many digits. This only has 6 digits. Data type double is used to store decimals with lots of digits. So this decimal right here has a lot of digits. These are the 4 types of numeric data types we will need for the course. So if you ever need to create a storage space for a number, you're going to use one of these 4 data types. You're going to create a box to store an integer in, or a very big integer, or a decimal, or a very long decimal. Those are the 4 types of boxes we will have. So let me show you how this works in the code itself. So let me bring this up. So just like from class, this code that you see here is given. This is always your start point. You always start with these 5 lines of code. And just like in class, don't worry about what they're doing for you right now. Where you're actually going to type code is right here inside of main. So let me show you how to create a storage space. So back up here, what was our example? Calculating area from a side length. Okay. So the first thing you have to decide is side length. What kind of thing is that? What do I expect the user to give me? And it's not going to be an English sentence or something. It's going to be a number. So you have to decide ahead of time, do you want to allow the user to give you decimals or just whole numbers? And if they're going to give you whole numbers, how big? If they're going to give you decimals, how many digits? So let's just assume for now they're only going to give us relatively small integers. The way that you create a storage space for the user to give you something is to type int. So you're telling the computer, I'm creating an integer box, right? A box to store an integer in. And then you have to give that box a name. This is how you will refer to the storage space. So that's a natural name to give it, length. Okay, so what we've done here is we've created a storage space for an integer, and we've called that space length. So later in the code, if I ever type length, the computer will know exactly what I'm talking about. It's talking about the value inside of that box. So if we're going to now ask the user for something, we can say, give us your length. Okay, and just like in class, by the way, the computer reads from top to bottom. So it's going to create this storage space first, then it's going to print this to the screen. Okay, now the question is, we've prompted the user for their length. Okay, we now want the user to give us the length of their square, the side length. How do you do that? The way you do it is with what's called a cin statement. It's like a cout statement, but backwards. So cout pushes text to the screen. Right, so we talked about this in class. These arrows are suggestive of like exploding to the screen, pushing to the screen. Cin brings stuff from the screen into the code. So the user types something on the screen and the computer grabs it. So what's happening here is I'm going to ask the user for the length, and the user is going to enter it. And then whatever number they enter is placed inside that box. So just to see how this works, Let me print this to the screen, and let me make sure everything is spaced nicely. Okay, so when I run this code, what's going to happen is you're going to create an integer storage space. You're going to ask the user for the length. This statement right here grabs it. It lets the user actually tell the computer what the length is, and then just to see that it worked, I'm going to print that value to the screen. So let me do something like this. Your length is. Okay, so let's watch this go. Give us your length. Oh, my length is 10. It tells me your length is 10. Okay, so it actually recorded that I entered a 10 here, and it put it right here inside of length. That's how it could repeat back to me what I did. Okay, so that's how getting stuff from the user works. You first have to create a space to put that in. Okay, you have to declare this variable. That's what this is right here. You have to declare it before you use it. Once you've declared it, you can put stuff in there, and then the computer will know what's happening. So there are lots of errors that beginning programmers make here, and I should mention a couple of them. These errors all go away once you've programmed enough. But let me just, for example, put that declaration statement here. Okay, so now what's happening is I will prompt the user for the length first, then try to grab it, then create a space for it. Okay, so then the computer will be sort of confused by this. Won't even compile. Okay, so it says use of undeclared length. All right, so what's happened is if you write the code like this, you're trying to put the length into a spot that hasn't been created yet. Okay, you have to create a box first before you put something into it. So if I put this back up here, now this goes away. Now this is the code as I had it before. Okay, so you always have to declare a variable before you use it. So a beginner's mistake is to try to use something before you've declared it. Okay, you simply cannot put things in boxes until you've created the boxes. All right, you can't use a storage space until you've created one. Okay, so there's one other thing to worry about here, and that is this storage space is of type integer. You can only put whole numbers in there. So let me run this code again, and I'm going to type right here where it says give us your length. I'm going to type something that's not an integer. I'm going to type 10.5. And if we were in class, I would ask you, what do you predict this statement will print? I mean, it's supposed to print the length, isn't it? So it should print 10.5, I suppose. But let's see what it does. Give us your length. I'm going to type 10.5. And it says your length is 10. Okay, so it didn't print the length that I entered. So why is this? Well, the reason it prints 10 and not 10.5 is because this length here, this length variable, only stores integers. So if you try to put a non-integer into it, the computer is going to truncate everything after the decimal. The computer is not going to allow you to put a non-integer in there. So it will take that 10.5 and make it into an integer by just forgetting what was after the decimal point. So it really is important to think about what kinds of things you're going to store in these variables before you use them. Because if you mismatch the kinds of variables that you have with what the user gives you, things like this will happen. So again, the analogy you can think about is, if you're going to put something in storage, you need to pick an appropriate box for it. Okay? If you're going to store a TV, you need a big, wide box, right? But if you're going to store something small, like whatever, a Kleenex box, you don't need a big box. You need something smaller. So if you try to fit a big TV into a little box, what will happen is the TV will get chopped into pieces. That's what happened to this 10.5. Okay, let me now come back to the slides here, and there are a couple of questions that students typically ask when I get to this point. So let me introduce the first one. So every semester I've taught this, students say, well, I don't like that 10.5 thing that just happened, that you just showed me. I want the computer to always remember the number I typed. So you can look at this list of data types and think to yourself, well, what is a double? Okay, a double is just a really big decimal, isn't it? Well, integers you can think of as decimals. You can think of 7 as 7.0. And you can think of this humongous number right here as 10 billion point zero, you know? So you can use double to store whole numbers if you want to. Okay, so like back here in the code, if I declare this as double, and I run this, it will work just fine even if I hand it just a whole number, right? So if I enter 12, it knows that 12 is the length. Okay, so in other words, integers are doubles, longs are doubles, floats are doubles. So in some sense, everything is a double. So why not just always declare your numeric variables to be double? And the answer is efficiency, because double is like a big box. Okay, when you create a double variable, the computer sets aside a lot of storage space to create that variable. But if you just want to deal with whole numbers, small whole numbers, you don't need a ton of memory set aside. You need a small amount of memory set aside. So it's just like, suppose you want to put a couple of pencils into storage. You wouldn't pick a humongous TV box to put those pencils in there, because that's a humongous waste of space. It's terribly inefficient. Okay? So the reason you don't just always use double is because if you always use double, you are wasting a ton of memory. And if you were an actual programmer writing actual programs and you've got, tens of thousands of double variables where integer would have worked just fine, then you're going to really slow down the performance of the program. The program will run extremely slowly. So just like in real life, when you're packing up your stuff to move, you choose boxes appropriately. You put small stuff in small boxes. You put big heavy stuff in big sturdy boxes, etc. So if you always insist on using humongous sturdy boxes, you're wasting a lot of money. You're wasting a lot of space. So that's why we don't just use double all of the time. You use an appropriate variable for what you are using to not waste space. Okay, so I'm just going to quickly wrap up this video. I'm going to finish that square example, of course, but I just wanted to mention that you can do basic arithmetic in C++. You can add, subtract, and multiply just as you would expect. You can do lots of other operations too, but we will save those for next time. Just one little quick caveat here. To multiply, you have to use the asterisk symbol all the time. That includes things like this. So in algebra, 2x means 2 times x, but you don't have to write the multiplication symbol. But C++ doesn't understand that. You always have to use the asterisk symbol if you're going to multiply things. Okay, so now let me do the area of a square example. Oh yes, and I wanted to mention here that when I say you can add, subtract, and multiply, that means that in C++, like I can now do, let me get rid of this for a second. I can just add things with the addition symbol. So let's watch this run. I'm going to give the program a 4, and it's going to output 4 plus 4 is 8. Okay. So plus, minus, multiplication, these things are all built into C++. You people do not need to teach C++ how to add. Okay, the people who built the language did that for you. But I did want to mention it's actually highly non-trivial to teach a computer how to add. Okay, the computer is doing everything in terms of zeros and ones. So this C++ language is like an interpreter between you speaking English and the zeros and ones. So the people who built this language made it so that you don't have to think about anything when you do addition. You can just use the symbol as you want to. But I mentioned that just to remind you that there really is a lot happening under the hood here that you can't see. And one of those things that's happening that you can't see is that somebody else has already taught the computer how to add. But again, it's actually a very highly non-trivial exercise to teach a computer, just in terms of zeros and ones, right, how to add things. But in any case, you can add, you can subtract, of course. So if you do length minus length, it will do what you think. Anything minus itself is 0, right? In particular, let's deal with multiplication because I want to finish this area of a square example. So let's just assume the user is only going to give us whole numbers that are relatively small. Let's finish this example. What was supposed to happen is the user gives us a side length of a square and we print the area to the screen. So area is also an integer if length is an integer. Okay, so the area is just length times length. So if length is an integer, so is area. So right down here, let's just say the area is length times length. And this statement right here, this is called an assignment equals. So what you're saying is what's on the right-hand side of the statement, please put that in the storage space on the left-hand side of the statement. Okay, so this is not equals in terms of algebra. This is just an assignment equals. What's over here gets assigned to this. Okay, so what's happened here is I've created two storage spaces, one for length, one for area. I've gotten the length from the user. Then I tell the computer, this storage space area, I want you to put length times length in there. And now we can tell the user what the area is. So let's watch this run. Give me your length, 4. Okay, well the area of the square is 16. So there you go, it works. So just briefly to wrap up here, anytime you do this variable equals stuff, again, it's sort of confusing until you do it multiple times, but what's happening is the stuff over here gets assigned to what's there. So let me just get rid of this and just write something like this, area equals 5. Okay, what I'm saying is that you need to put the value 5 into the variable area. So now when I output the area will just be 5, no matter what the length is. So the computer grabs the length right here, but then I'm just telling it, I want you to assign a value of 5 to area, and it does. So now the area really is 5. Okay, so now that we finished this video, you now understand how to grab things from the screen, from the user. The way that you grab something from a user is first you create a storage space for it. And by the way, it's just convention to put your storage spaces all at the top, to declare your variables at the top. It makes the code much more readable. So you're telling the reader, who is me in this case, what all of your variables will be. So notice I could have put area down here, okay, but I didn't because it's just clear what's going to happen in the code if I put them all up at the top. But in any case, if you want to grab something from a user, you first create a storage space for it. So you decide what kind of thing the user is going to give you. You give that space a name, and then you can put things in there via a cin statement. So that literally grabs something from the user and puts it in there. Or you can just assign things like this if you want inside of the code. But that's how you can make a program interactive. That's how you can create places to put numbers. So in the next video, we will just continue the thread at the end here. We will do these other operations, among other things. So